Okay, today the first thing that we are going to get into is motion. So we're going to start with a question here, and that question is, what is motion? If I were to ask you to describe to me or define that word for me, what would you say? Now, here we have a person, and we can see that this person is moving. The question I want to ask then, how do we know that he is moving? Well, that seems pretty simple. He went from the left side of the screen to the right side of the screen. So that brings us to a second thing we need to think about, and that motion is relative. It is relative to your surroundings. Now, something I want you to think about here. How many of you have sat in a car and after a while you jump up and you jerk after sitting there because you think that your car is rolling backwards or rolling forward, but it really is not. It is the car that beside you that has started to move. So what gives you this feeling or this thought in your mind that the car you sitting in is moving? That is because of your frame of reference. A frame of reference is what we are comparing the movement of an object to. Okay, so as you were sitting in your car and waiting, in your mind, all the cars around you were stationary. So when you notice a change in your frame of reference, the car beside you, and you in your mind believe that car is stationary, well, that must mean your car is moving. Okay? So movement is based on, or relative, I should say, to your frame of reference. So, again, we have our runner. We have a tree. We can see that the guy is passing this tree. Okay, we know the man has moved because we have compared him to the stationary tree. So in this case, the tree is our frame of reference. Okay, we sometimes refer to this as our reference point. Okay, reference point. So let's look at the next slide here. We have a picture, and you can see there at the top the cows are standing up talking, and one of them yells car. Car comes up over the hill and moves on down the road, and then the cows get back up and begin talking again. Okay, now, did you really see the car move, or in your mind do you think that the car has moved? Okay, something to think about. Now, why did all of you say you thought the car came up over the hill and went down the road? What was your frame of reference? Okay, you see that the cow on the top one yells car, even though there's not a car present. Okay, and then in the second picture, the car is up over the hill. And then in the third picture, it's gone. So what were your frames of reference that said that the car was moving through the three pictures? It could have been the road. It could have been the cows, because you can see there that in each picture, the position of the car has changed relative to the cows. Maybe it's the fence. Maybe it was the grass. Any of these could be used as a reference point to say that the car was moving. So again, I just want to point out that motion is the movement of an object relative to a point, and that point is called the reference point. Okay. So, with that said, you don't always need to see something move to know that it's moved. Again, you do not always have to see something move to know that it's moved. For in the picture that we saw before with the car and the cows and the road, in our mind, we know that that car drove down the road. It moved. Let's look at another example of that. I'm going to show you a picture of a coffee table. You can see that on that coffee table is a lamp with a genie, and it's in the back left corner. I look at this second picture, and I bet all of you will have told me that the lamp and the genie have moved. If I asked you to explain the motion, you would say that the genie moved to the right from left to right on the table. And if you look closely, you'll actually notice that the genie and the lamp move slightly forward on the table. Did you actually see the genie and the lamp move? But yet, you know it moved because it changed its position relative to the table. So our reference point to describe this movement is the coffee table or the top of the coffee table. Again, you don't always need to see something to move to know that motion has taken place. Okay, so we are going to get here into motion, and we're going to talk about different things such as speed, velocity, acceleration, and then we'll eventually get into laws of motion. And go from there. So, something we need to talk about first is the difference between distance and displacement. Two similar but different terms. So we're going to go through here very shortly and talk about distance and displacement. Now I'm sure all of you know what distance is. However, probably most of you are not sure what displacement is. Hopefully when I'm done here, you will, and then doing your assignment will be quite easy. So let's move on with distance and displacement. Here we see distance. I'm at my house and I have to walk to school. So I'm going to walk half a mile to the east, a quarter mile to the south. I'm going to turn and walk another half mile to the east. I'm going to turn and walk another half mile to the, or a quarter mile to the south, and then make one last turn and walk another quarter mile to the east. Okay, so what was my distance? My distance is the total space covered along the path. So if I simply add those up, I would have to walk 1.7 miles from my house to the school. Aren't you glad you don't have to walk that far? Now, how does that compare to displacement? Okay, so let's talk about displacement. Here is our little map showing the distance from the school to my house. To do displacement, what we are going to do is get rid of all these numbers. We're going to get rid of all these turns, this road with all of its turns, and we're simply going to take a direct path from the house to the school. This is displacement. The direct path from one point to another point in a very specific direction is what we call displacement. So even though our distance from my house to the school was 1.75 miles, the displacement is only 1 mile. And if you read carefully Displacement is in a particular direction. We're going in a straight line this direction. If we were to use our cardinal points, we are moving southeast, okay, or toward the school. Now you should know a little bit about the difference between distance and displacement. The next thing you have to do is watch a very short video that is going to also go over distance and displacement. If you didn't fully understand with what I said, you should get it after you watch the video. Once you completed your video, you should be able to easily do your worksheet. You will need a metric ruler to do this worksheet. Okay, so you might want to stop by my room if you don't have one, so that you can do the assignment. Hopefully you've already taken care of that beforehand. Thank you.